robotics build. Today I just wanted to talk to you about a few of the common procedures that you'll be doing on a robotics build team. And I can't go over everything because that will take way too long, but I just want to show you a few of the primary things that you'll be doing just to get you into the knack of it. We're going to do a cut on the miter saw. So the first step for that, again, is just marking where you want your cut to go. And I'm going to say right down here. I have it plugged in here, and I'm going to release it up. Now, if I wanted to change the angle, on this one, the lever is at the back, and you just loosen it, and then you can tilt it. And on the other side here, there's a little protractor, and you can set it to the angle that you need. So I'm going to line it up here, and on this one, you have to push the button in at the top. And so I didn't cut exactly on the line there. The laser on this one is kind of faint because it's an older machine, but you could kind of see it coming down there, and I could have done a better job lining it up. But when you're cutting, just make sure you line it up with this fence here, and you turn it on, go straight down, up, and release. And the same with this one as all corded tools and tools in general. You want to leave them in a safe condition, like that. And now, if I had a guard on here, the guard would be protecting the blade, and it's locked, safe. Alright, so in this demonstration, I'm going to show you guys something that you will do pretty much every day on a robotics build team, which is putting things together with nuts and bolts. So what I've got here is a bracket, which I'm going to attach to my piece of aluminum. Now, I want to point out to you before we start is that this piece of aluminum here has fresh cut edges. So they are razors right now. So on your robot, to pass the safety, you will have to file down all the edges, which you do just by going at an angle with a file, one direction, until you take some of the edge off. So the first step to putting this bracket on here is to drill a hole into our aluminum. And I'm going to do that with not the impact driver, but the drill. So I've got the drill here and my drill bit. And when you're choosing your drill bit, with bolts, it can be larger, but if you're working with wood, like a screw, if you're trying to put a screw in, you want the thread of the screw to go into the wood. So you'll want the drill bit to actually be smaller than the screw itself. So I'm just going to put this in here by twisting the top here until the little fingers come out and grab on, and twist it a few times. And then I want to make sure my material is clamped down. You can either secure your material overhanging the edge of your work surface, or you can have another piece of wood or something that you don't mind getting a few holes in. And there, it's nice and secure. And now I want to just mark where I want to put my hole. And you can do that with a Sharpie on metal. So I'm going to put it in right there. And when you're working with metal, sometimes it takes a while to get into the surface. So it might be good to use a tap. So what I want to do is get out my nail set here, which is just a piece of hardened metal. It's harder than the aluminum. So you can just put the point into the center of your hole, give it a few whacks, and there'll be a little bit of a mark. And then the tip of your drill bit will just nestle right into there. I just cut this like this. It might have more sparks. Aluminum doesn't spark too much, not nearly as much as steel, and it will also squeak. So to prevent that, before we start there, we're going to use our cutting fluid and just put a couple drops And now we are set to drill our hole. Now you can clean up the shavings a bit, and you can do that with a cloth. Don't use your hand, they're very sharp. Now I want to put my nut and bolt in. So what I'm going to do here is I'm just going to feed the nut through the hole and put the bolt on the other side. And you can twist it in a little bit, but then you'll find it has some resistance. So the nut I have here actually has a bit of rubber on the inside, and that helps it mimic a lock washer a little bit, and it keeps it from falling out. So next I want to find my wrench that is the same size as the nut. And the ones that we use a lot on our team are the 10 millimeters, which would be the metric measurement, but in SAE it's roughly 3/8. So now we need to find a way to hold this part here. And that can be done one of two ways. So the first way is with a slotted screwdriver, and the second way is with a Robertson. So there's many ways that we can go about putting this in. Some are more efficient than others. So with this, you could either use a wrench and a screwdriver, or a screwdriver and a ratchet, or an impact driver and a wrench. So you have figured out we can hold the nut here with the 3/8 wrench, but we can also hold it with a ratchet. Now I've got some metric ratchets here, and this one is 10 millimeters. I can pop the socket onto the ratchet right there. So both of these will fit around the nut that we have in there. But if we tried to turn this, tighten this, it would just turn the whole system. So we need to hold the bolt down as well. And we can either do this with the screwdriver. In this case, that would probably be the easiest way. Or we could use our impact driver if we're doing 300 of these and we need it to be pretty quick. So I've got a set here of impact bits, and I'm going to choose the Robertson because Robertson tends to have a much better grip than a flathead. In that set, it didn't even have any flatheads. So this one is the correct size, yes. And I'm just gonna pull out the end here and put in my bit and then let go of it, and it's tight in there, good to go. So ideally I would have left this clamp down, so I'm going to clamp it back down. And now I'm going to hold one side with my wrench, and on the other side I'm going to put in the bolt. So we figured out how to put our nut and bolt in. It is in there 100% tight and secure. But we didn't put on our bracket. So we've got to take that off. Now how do you do that? Well, it's pretty easy, you guys. There's a little switch on here, and it's got a left on one side and a right on the other side. And we've got lefty loosey and righty tighty. So if we've got the left side pushed in, it's going to loosen things. Wrench on the back, our impact driver on the front. Press the trigger, and you see the nut just fell right off. Alright, and to tighten it back on, I'm just going to use a slightly different way. I'm going to use a screwdriver instead of the impact driver, and I'm going to use the wrench. So we do the same way as before. Turning it left will loosen it, turning it right will tighten it. So I want to turn it right, so I'm just going to put that on there. So notice you can either turn the wrench, or you can turn the screwdriver. And there, it's nice and tight again. So that's something you will be doing a lot on your robotics team. And one thing to remember is that tools come in all shapes and sizes. So don't be afraid to look for the right tool that you need for the job. Alright, so I'm going to show you how to use the table saw. So I'm going to do the demonstration on a piece of wood here. And one thing to note about cutting wood with any kind of blade is that there is a difference between cutting with and against the grain. So if you cut with the grain this way, you can see that the grain is running in general up and down the board. So if you cut this way, that's called a rip cut, and it's much easier to do a rip cut than a cross cut because you don't have to break as many of the fibers in the wood. You will mostly be cutting either Lexan or metals, so you might not have to worry about this as much unless you are on the bumper team. So to start this cut, I'm just going to make sure that I don't have any hazards around me, which I don't, so we are good to go. And I'm going to mark off my cut just to start. I want to measure multiple times, so we're going to measure twice. I'm not doing a specific measurement, and we want to try to avoid the imperfections on our final cut as much as possible. So it's got a few nicks here and a knot here, so we're probably going to try to use this part here. So now we are going to adjust the blade to the proper height. And that looks good. It's just above the level of the board. And next, I want to line my board up with the fence. So we're going to release the fence, move it over, and we want the part that we're keeping to be between the blade and the fence. So I'm going to line it up and move it back, just right there. And then, since we've got that all done, we can turn the machine on. Now, if you were doing this with a large piece of material, you'll want to have someone else standing on the other side to help you guide it through. One thing I was missing though is my push stick. So right now I'm just going to use another piece of wood as a push stick, but ideally you would have a plastic one. And I'm going to turn the machine on here with the material out of the way. So one thing you'll notice with the table saw is that it does kind of lift up and out of the way. So you'll want to have a push stick that has a notch in it preferably, so that you can push down and towards the fence. So you want to kind of be pushing in this direction. So this was just a small demonstration of a few of the procedures that you might go through on a first robotics team. On your team, you will definitely be using some other tools. So just ask your captains and your coaches for some instructions on how to use those. As well, don't forget general shop safety. At the end of the job, there's a few things you need to make sure are checked off. One, you want to leave all your tools unplugged. You also want to leave your workspace clean and clear. And finally, and this is very important, you want to make sure your tools are turned off before you unplug them. Because the next person who comes along to use it is going to plug it in and it's going to start moving. I hope some of these tips were helpful and that you will have a great season on your robotics build team.